Alright guys, I wanted to go back and do some remedial dub over of some of these videos. So I just want to jump into this really quickly. What you see is my environment as I showed you inside of Topogun. And what I'm doing is doing some topology based on symmetry. And generally when you go into Topogun, if you hit X, you can actually draw out faces and edges and verts in symmetry mode. So if you notice on my screen at the bottom half, there's probably a highlighted little button that says symmetry over to the right hand on the bottom. And what this does is I go in and out of this mode because certain faces I want to edit in symmetry and draw so that they'll be balanced on both sides. And in the end, that keeps me from going back and having to, do any repairs on the mesh or doing any mirroring. And so, I go through and I've, sort of resolve all of the geometry in its edge flow. So anywhere where you see spots where I have two connecting vertices, like here, there's a small red hairline. That's me using the bridge tool, which is a really cool feature within Topogun. What this does is if I have say like two edges that I need to connect together to complete a face, I can draw out the verts and then simply hit Shift B on the keyboard, which will connect all of the vertices together by the edge. And then once I close a quad, it'll fill in gray, as you can see on the screen. So really what I have loaded is when you first open up a project inside of Topogun, it'll ask you for a scene, and then it'll ask you for a reference mesh. So the reference mesh is the helmet section, like the concept mesh that I had solid inside of Zbrush. In fact, I think this model in particular was not the final head. I think the final concept head I put together in parts. After I did one round of topology, I think I parted it out, and then I detailed each individual part that had been retopologized, and then I tried to do an outer shell for each piece. Probably later on in this video you'll see. But I had a couple of different runs to get to the topology that I am now in Marmoset that you've seen in class, probably in the last, week or two. So I'm just building out all of my edge loops, and I think this was probably the plated pass of topology. And when I go through doing these things, I kind of do a number of topology passes over the original model, and it's more or less so that I can find the most optimal. I think the final ended up being at about 4,200 some odd polyfaces, and about the same for verts. So it's just under 5,000, I would say. So once I build topology for each plated modular section of the helmet, I think I took those back to Zbrush, and I believe I pieced them together. So it's kind of a combination of doing some topology after I've developed the Dynamesh up to get my reference, and that will become the basis for my model doing just like a high poly. And then the low poly cage is what I'm working towards, because once I have it high, I can project all of the high details over to that lower, more optimal geometry. So it's kind of a trick of a thing, basically. So here I'm working on sort of the top plates, and I can already see that in some places I'm having some issues getting the symmetry balanced out. And so, that's why probably I turn symmetry on and off so I can do some edits. And, once the mirroring is there, I can just work from there. So basically, you're kind of almost I'm not sure if you would necessarily say mirrored UVs, because when it came down to doing the UVs, they weren't necessarily butterflied open, but they were cut into equal pieces. And later on in this video, I think I'll probably take you through a run of one of my UVing passes through Headus, which I haven't had much of an opportunity to talk about in class. But it's a wonderful program if you're going to be using some sort of efficient UVing tools. Some will ask why I don't do a lot of UVing inside of Maya, and to me, I just find that Headus has probably got one of the better algorithms for flattening, and its tools are very easy and intuitive to grasp. It's a very simple, elegant program to do topology in, or excuse me, UVs in, not topology. Sorry about that. So I'm making my rounds around the helmet, probably one of the forward pieces. And I think, one of the things that can speed up this process, especially when you're trying to resolve a lot of very difficult, tight turns in some of the topology, is making larger faces work at first and then adding geometry in by adding extra loops. That way you can kind of capture some of the resolution around your object. So what you'll see me do is maybe make some more broad general lines of vertices to capture some of the edge flow, and then I'll come in and do more finite smaller sections like what I'm working on now. So there's like a little inset piece here, but I need to make sure that all of the loops line up and all of the curves line up, because what I'll do is once I have these lower poly pieces put together, in other words, all of the modular pieces retopologized over this reference mesh, I'll take those then back into Maya and I will extrude the edge. So if you remember in Zbrush, you do add skin thickness. It would be about the same thing as adding skin thickness to the topology. Only this time, I don't have any skin thickness while I'm working in Topogun, so I have to kind of recreate a lipped edge, but I don't, for UVing purposes, want to add back faces. So the back side of the faces of, if you were to do this, say, in Zbrush alone, that's entirely possible. It's just sometimes I use something like Topogun because it's a little bit more efficient of a topology tool. It's a very simple, like I said, voxel, poly layout. I can use a lot of, bridge tool snapping and gain some, face geometry really quickly. I think, in fact, I took out some of the speed that was in this demo. I might have given it to you earlier because of, this is week 7, and parts probably captures 2, 3, 4, 5, 6, and 7. So there's about 7 clips that make up this, the entirety of this capture. And one thing that I will warn about with using Topogun, I've talked about it a lot. It's a really great program to use. It's very inexpensive to acquire. You can buy it directly as a download from their site, and I should probably later provide links for that. But one of the things that I would be very careful and warned about is every once in a while, if you're using the bridge tool, if you accidentally snap on an edge that has already been established, or by accident double click it, it can cause in some ways some hidden or doubled faces. And so, if you're going to use an outside package like Maya or anything, it may be a good idea to go back and do a mesh cleanup, or check your faces, your geometry through mesh cleanup, because what it can do is always view it turbo smooth in Maya, which would be a good thing. And if you see any errors there, more than likely that might be what has happened. Even so, sometimes, every once in a while, this can happen in Zbrush, doing topology there. You might have some unresolved meetup of different points where, like, say, a vertex didn't snap correctly on top of another one, and what you'll get is probably like a hidden triangle somewhere. So just to you know be really careful about what you're laying out, I would say run a mesh cleanup and see if you have any errors on your mesh. So right now, I think I'm selecting a circular loop of faces and getting that inset geometry by using the extrude tool. So if you do a selection, I believe over to my left hand side, there's tool options there, which would be, I believe, the selection for verts, edges, and faces. And with either of those three selected, you should be able to use the vignette tool to grab, like I'm doing right now, each and every edge of the loop, and then pull the extrude handle out. There's like a widget that shows up when you use the extrude. So extrude being the very last icon on the toolbar over to my left hand side. So right now I'm just doing bridges using quad geometry for this poked circular face. And so, it's like the base of the quad would have three, and it's almost like a quad triangle. So here I'm doing a quick projection test. You can check your subdivision and how it would project onto your retopologized pieces by hitting subdivision and then preview. And if you look closely for the settings under subdivide, you will see a spot where you'll be able to set it either for optimization for Zbrush or Mudbox. So since we're using Zbrush, I of course chose Zbrush or ZTL style projection, and then used I believe it was about 3 or 4 subdivision levels is what it's projecting, and just as a preview. So it takes a second to calculate it and then show me the projection and see how the geometry pairs up well. So I think I skipped over to Maya just for a second and did a check on the mesh, and as you can see, this is plated. So each and every piece has of the helmet has been retopologized, and then I think I start from the back pieces and create some just the lipped edge by extruding it. So I use the world space widget there on the extrude tool and just slightly push it outward towards the inside of the helmet. So I do this for each and every piece. That way, again, we have no back faces, just an outer lipped edge. And as I subdivide each and every one of those little modular pieces, it helps me better pair up the seams of the helmet. And so I think I went through this a couple of different times, topologizing and getting it right. So topologizing a piece of mesh is a process that, once you get better at it, once you get a little bit more intuitive about laying out your edge flow and having it match your geometry, it becomes second nature to you. But I don't want any back faces because, of course, with UVing, if I had back faces, I would literally be applying texture to the inside, which I don't want to do. I just want the outer side shell, and the center on the inside would be hollow. And that way also I'm not really getting any serious projection errors. So I think I later took these modular pieces, and after I created an inside lip to each modular piece, I think I did some creasing and subdivided it up to about probably level 6 or 7 for most of these pieces. And then I took and sculpted in high detail. So in other words, anytime that I'm using an alpha stamp, I'm plugging them in to the more retopologized pieces. And then I saved out the whole helmet as a decimated model and brought that back into Topogun and did a final topo pass on the entire helmet, which was, I guess you would probably call more of a manifold mesh. So in other words, it's the entire helmet and it's airtight. So I think the only holes were probably at the bottom where the neck piece would fly in, or probably be stacked on top of. So I'm just doing a little bit more extruding on the edges. And every once in a while you'll see me probably do a little turbo smoothing to see how some of the softening would happen, how some of the subdivision would happen. So when you're at this stage in Maya, generally, if you're going to do an extrusion of the lipped edge, what I would do is grab the outermost edge and double click it, and then of course use the extrude button up top in the polygon menu, and then just push it slightly inward. It would be the blue handle on the extrude tool, which is pushing in. One thing to be careful also is when you're pushing in that extrude, you may want to take and just make sure that none of the edges geometry, like the edge pieces, are actually crossing over, because I know sometimes the offset can be a little bit weird. So sometimes you might have to relax your mesh or smooth it out a little bit so that the inside lip is doing its job, or reinforce it with reinforcement edge loops. So here I've gotten all the pieces in, and I think I tried to do a little bit of projection, but polygroups, auto group all, and then I believe merge similar polygroups together got my symmetry for each section pretty much right. So in other words, the jaw is one piece, the muzzle is one polygroup, the head eye socket piece is one solid piece, but these panels that are off to the side, all of them, if you auto group it, it'll put different polygroups, and then if you merge similar polygroups, of course the similar pieces are going to get joined together. So when I worked with this mesh, I think I found a few, and I'm not sure exactly how this happened, but I got a few little tiny faces that didn't connect right. So I go back into Maya and just use the polygon draw tool to fill it in. So that one is pretty easy. You just, click two connecting edges, and it's almost like a bridge, but it does weld it. So if I try and, go ahead and turbo smooth it again to just, have a look at the smooth preview, I know that all of the points are welded because it should properly smooth out. So I think I'll test that after, you'll probably see me test it out after I fill all of the tiny holes that broke up some of my geometry. And on the inside of this mesh, you can, with a few, parts, modular parts turned on, you can see the inner side lip, and all of the black faces are all of those that are on the inside of the mesh. So I'm not displaying, faces doubled or anything like that. I'm just, all of the normals are pointing outwards in their correct position. If you're savvy to either probably Max or Maya, I'm sure there should be a display normals tab. And so I think here, after I fix one side again, I just did a mirror. So if you see me cut it in half, it's not me really literally destroying the geometry. It's me being a little bit non-destructive by just coming in and fixing one half, and with the repaired half, just flipping it over by, I believe it's probably one of the mesh tools menu, and then you want to bring up the mirror function and or the mirror with its control tab, and from there pick which direction. So I think probably on the X negative is where I mirrored it over. So I'm doing a little bit of move to move over some vertices, because I think some of them overlapped, but the geometry wasn't joined, so I'm just doing a little bit of repair work. And I re-import this to Zbrush. And generally, if rather than using GoZ and mixing up a project or doing something wrong, I'll save it as an OBJ from Maya, and then I think either probably import the tool and then append it. Uh, or I believe if you append a piece of geometry, this is one thing that's kind of strange about ZBrush. Usually something I'll use something like a simple primitive, that's appended in my subtool groups. And then on that dummy, primitive, what I'll do is I'll actually import the OBJ model, and then it puts it right in place. So here I'm doing a little creasing with the Z modeler tool and using site dynamic subdivision to get it hardened up. That way I can actually preview some of my creasing and see how things come out. And you may notice that sometimes, like when I did the topology, there are a few details that are missing. Anywhere where I used an insert multi-mesh, like there's a few different types of rivets or screws or hex screws that I put into the design. I used the transpose tool to select and mask those, and then did a split unmasked. So I took those out. So literally what I have topologized is, sort of like the base form of my helmet. So none of the smaller details. I think I can put those back in as separate pieces of geometry. And then when I do my overall manifold mesh, it's a little bit cleaner. So I can kind of anticipate, what details are actually going to be inset geometry and what details are actually going to show up on the manifold mesh. I think probably in the final pass, I created enough geometry, especially for a lot of the circular designs that are in the helmet, like any type of rivets or like the eye optical area. What I did was I just made a lot of circular loops that were straight enough to accommodate the geometry. And then when I subdivided and did a projection, there was enough of the cage to capture the detail of all of the insert multi-mesh brushes. And I can show you a demo of this in class, or probably in other parts when I show you the final topology, you'll probably see it. But like say if there was a bolt sticking out of the helmet, I just built up the geometry right over that, and when it projects, it has enough geometry to capture that in normal information. So not really a whole lot of detail was used in either a height or a displacement map. So, and here I think I did a little preemptive texturing, mostly for look development, in my marmoset file. And I think this was probably a second pass in Quixel that I did, and then I think in my third and final pass is what you've been seeing in class. So I kind of had a general color scheme and lighting idea in mind, and so I think this is probably one of the easier runs where I'm, first or second. Yeah, I think it was second, because the first I think I had some parts that were blue and yellow, and then I wanted to try a darker scheme. So I'm doing a lot of look development as I get this map, the maps for this done. And I think the torso section was done first, and then the head was done second because of the complexity in the design of the helmet. I had to do quite a few, topo fixes and projecting that. And there was a couple of, as far as UVs go, there were probably 2 sets of UVs done to get it right and to get it done solid. So probably when you look at the next set of me, doing real-time rendering in Marmoset, it's quite further along with decals and everything. And some of the lighting environments have been significantly changed. Some of the focus, depth of field effects. So this is a color ID map, and checking probably color IDs. I think in the earlier runs I did a color ID, a normal, an AO, gloss map, and albedo map, and probably I was using specular and/or specular advanced metalness, which used a metalness workflow and specular, but I should definitely be talking about that later. So here I'm going through the pieces in ZBrush, And this is a good opportunity to talk about taking some of those individual topologized pieces and working the forms up. So not only creasing, but I think I added a lot more detail with alpha stamping, and then finally spots like this where I used a piece of insert multi-mesh. I think this is a small little piece that I got from one of the kits by Vitaly Bulgarov that I used as just a cog at the, or like a port hole at the end of the helmet's mask. And since again, I'm moving it around and doing it, doing a little bit of tweaking and adjusting and setting it into the geometry, because I really don't want to have to build up that geometry over that. So when I did my final topology, I had all of those smaller little insert meshes that I use for noise design on the helmet in actual geometry. I think I had to crease some of these or fix them somehow, because sometimes they can, if subdivided and they don't have proper creasing, they can kind of distort the mesh. So I think finally I had to go in and do quite a little bit of topology just to detail those sections out. Because a normal projection will only give you so much detail. If there isn't enough supporting geometry behind it, some of those details can get really broken down. And so, you have to kind of pick your battles as to what you're going to topologize and model, and what will actually show through in the end result. So here I think I'm using the rotate and also move tools to get the cog in place. And I think I had to smooth out the bottom part of the mesh because, as you can see, there's probably at that vertical slat where the screw hole is, there's a little bit of mesh poking through. So I don't want any distortions, so I turn it and I get it right. And do a little bit of rotation here. And again, with these videos, I think I might have given you guys a version of this that was silent, but I wanted to come back and dub it over and do a little bit of explaining and slow some of the videos down so you can see what I'm doing. So I use an H polish once that's creased and flatten it out. Then I put the detail back on and nothing's poking through. It looks like solid geo. So at this point it's starting to look really formed up because of the creasing being in. So I believe if I look at this a little bit closer, I'm checking my dynamic subdivision, which I don't think I've committed yet because I'm still maybe messing with the topology somehow. These are some insert meshes, and I quickly insert them and then separate them so that it's a separate subtool that I can manage. Because after I add some details, I may have to go back and kind of move some of those pieces around and adjust them, because I'm mixing insert meshes with some alpha stamps. So like maybe I'll make a screw hole impression in the alpha brush that I'm using, and then I'll put a bolt on the inside of that stamped detail, and it does really fuse together quite naturally. It looks nice because the manifold mesh that I'm building over that will capture all of that geometry as normal information. It literally will be flat on the actual geometry, but the projection of detail gives you the illusion that something is actually sticking out of there. So I just put them in and split them and then separate them into separate geo. Give them a name so that I can properly keep track of them. So you see me, showing and hiding these details. So there's the stamp. I think I'm using drag dot for the outer edge of it, and then have the bolt come through. And then on the center of it, I'm drag dotting an actual inset circle. And so that creates the sort of recess for me to put that small screw into. So I hide it, get the inset circle towards the center a little bit, and now I can just use the transpose to move that insert detail right at the center. And I'm changing the axis and pushing it in a little bit. And once I get it flush, I'll just leave it right there. So you probably see this cylinder that's poking through on the other side. That's literally the back side of that rivet going through the other side. This doesn't really make much of a difference because in the projection, once I do an outside cage that's retopologized, the manifold mesh that I spoke of, those details won't come through. None of the backside stuff will come through. What really matters is all of the face value stuff on the outer side where you're actually looking at the model. So I do a little smooth washing. I increase my brush size, and I want this to look, the creasing is a funny thing. It can make some things look a little bit too hard. So if it looks too hard, what I do is I usually take a standard brush and change it, hit shift and hold out the smooth. And then, there's that hidden algorithm that you remember I might have mentioned. So there's two smoothing algorithms to really fix and kind of polish. To take and knock down the edge from the creasing, I do this so that things kind of have a molded look, but not, I don't want it to be an absolutely hard creased edge. Generally, if you're not using the smoothing brush to do this, or shift smooth, what you can do is also give it just maybe 1 or 2 increments of smoothing on the deformation palette, and what that should do is knock some of the sharpness just ever so slightly down. So I'm using those mod cuts to put in some cut lines and a small sort of pitted alpha, a mechanical alpha that goes into the mesh. A little bit more smoothing in some areas. And I'm using a sort of inset square or rectangle alpha for some vent-like grooves. More of a grip than anything. That brush, I know some of you have asked me about some of these brushes. If it's not the maw cut, there's a few other either circular detail or those little tiny rivet pits that I've put in. That brush actually comes from Mike Jensen, who, after purchasing his E3D hard surface tutorials, which I would suggest to anybody, even if you're not a regular hard surface artist, the knowledge of Zbrush, which for its time, when that video came out, I believe it was like early version 4. I think Dynamesh had just come out in his part 2, but they're definitely still relevant tutorials to watch, so I would definitely check them out. If I didn't mention it in class, go ahead and check out Mike Jensen and his Eat3D tutorials at e3d.com, I believe they are. There's a few good videos put out by E3D, not just for hard surface, but also organic stuff, and they vary, not just ZBrush, but a couple of other different packages. But some of the free stamps that he got out in that video series are golden. I use them quite a bit, actually, for alpha stamping. There's not a whole lot of brushes that I actually, like alpha stamps and stuff like that. I just don't sit and collect a bunch of them to have on hand. I use them sparingly, or I make my own, which hopefully in one of the last videos that I give you guys, where I go over a few different smaller remedial things in Zbrush for hard surface. Alpha stamping was probably at the top of my list. Unfortunately, I didn't have time in class to talk about it. But if you've ever made an alpha stamp, it's really an easy kind of thing. Just a couple of different things to look at to make sure that they work right. Mostly the radial fade at mid value, which you'll notice is docked into my own personal UI. So I don't adjust my UI a whole lot, but out of what I do, some of the UI elements at the top, upper right of my screen have things like store morph target, mid value, radial fade, grab dock. Those have to do with creating a lot of alpha stamps a lot of the time. Okay, so I got it detailed out for every plate. And by now I should probably have a lot of details put in. So I take the whole mesh and I decimate it. And so this is what the decimation looks like. Decimation turns everything from the quad polys over to tris. And what I did was I merged visible on all of those. And when I merge visible on just the helmet alone, it creates an actual separate tool which will automatically be called merged, and then whatever the title of the tool was. And I take that and I decimate that. So remember, probably if you're going to do any type of decimation, you want to work on a clone or an actual merge visible copy of your actual tool. That way you can decimate it separately than your actual tool. In fact, this entire project I've actually saved as a Z project. So having the project together, all of the skins that I've made either through topology or the imported helmet pieces, I've separated out so that they're standalone pieces. That way I can develop each one. So as you saw me topologize, I think I had all of the pieces probably put together, then alpha stamped and detailed, and then merge visible, and then from that grouped merge visible, I actually decimated it and then put that back into Topogun to do my final cage. So I'm kind of back to Quixel and showing a few things from the torso and looking at the normal and trying to do some post effects on the maps, going through and looking at cycling through different maps in the 3D previewer, and also checking some of the lighting environments. There are quite a few that resemble some of the same environments or use some of the same environments as Marmoset, but they offer in 3D, which fully rivals the use of Marmoset. And in fact, it looks exactly like it in a lot of ways. I think some of the similar technologies went into it. But also, it has Unreal lighting, which is awesome to use. So again, I'm flipping between Topogun and Maya, doing some minor checks, probably retopologizing a bit. And I think that's my decimated, which I tried to set normal angle on. Normal angle, if you're unfamiliar, is a way of setting the degree at which the normal is displayed. And I did this in Maya so that when I bring in this reference mesh into Topogun, I could try to maybe minimize some of the weird lighting issues on certain faces. It's kind of hard to explain, but when I decimated the mesh, every once in a while you get faces that are triangulated that show up strange and have a little bit of this burning that you see on the edges of the model. And that kind of can be helped and or reduced by changing the normal angle. So if the normal is being viewed or lit beyond, say, 45 degrees, some of those burns won't happen or will happen, varying on what angle you set it at. So I think I took the model later after putting some UV. I think I put like a used UV master to make a UV shell, and that came by way of the Z plugin, and I think UV master. And then I used symmetry and polygroups checked to unwrap all, which is this. And so it took each individual modular piece and flattened it out. And then I think after that I went into Headus just to check. So this is probably like my first or second pass. It's definitely not the final pass of UVs that I had to do for this thing. But I think I tested it out in a couple of different ways, thinking that maybe I could do a projection based off of each and every piece in Zbrush, and then, with those individual islands, get those UV'd very quickly. And it did work for a test, but it did in the end work out to have all of those pieces put together in one manifold mesh and then make individual cuts along certain parts of the geometry a little bit better. So this is Headus UV layout, and what I'm doing is dropping each individual piece and then cutting along the seams. I'm going to actually go over Headus a little bit more in detail in another video capture that I think I have for the final UVs. But basically, I'm using the algorithm to kind of flatten it out. And so what you're seeing is the more green areas are those that have less stretching or distortion. And the red areas are going to be a little bit stretched. And the blue, I should go back. The red areas are probably going to be those that are a little less optimal. So in other words, you may get some distortion. And I know that the blue areas are either probably a little bit stretched. It's kind of hard to explain, but once it runs its algorithm, which is usually on the keyboard, I believe Shift F, and then spacebar to stop the algorithm, you'll notice that it flattens. And when it flattens, certain corners or certain parts of the geometry may have a slight tint of red, and those are probably the less optimal. And the areas where you're going to get stretching are those that are going to be either a light blue shade or intermixed with blue. So those you have to be very careful of. Like some of those circular details, it might serve me best to actually cut seams in and around those, and then stretch them out so that there's no distortion. Sometimes it can't be helped. It just depends on the topology and the cut of the UV. As you know, with UVs, it's always best to make them where they're less visible to the user, and sometimes there's just no hiding them. It just depends on the actual cut. So stray pieces of geometry where I cut and I need to reseam, I'm actually taking those and hitting the W key, which will weld, and the M key, which will act as a magnet in between two pieces of geometry, or the UV shells where they're broken. So sometimes you'll see me cut certain parts off, or here where I'm actually just magnetizing and then hitting W to weld them back together again once they're flat. So I do a lot of cutting and then reseaming of a lot of these pieces. To make this work, what I should have done is actually in and around the circles of the eyes or circular details where there are circular loops, actually cut those out would have been probably better. Cutting them out would have been better. But I think I'm doing some flattening and welding here once again, and then welding that, rerunning the algorithm to flatten it. And sometimes with its algorithm, you kind of have to let it sit and run for a while until it absolutely stretches out the best that it can. There is an optimal or optimize tab that you'll see in the menu over to the left-hand side. And optimize will run the flattening or algorithm a little bit more. You can set a time, so like say 1 minute or 2 minutes, and that should actually make the pieces a little bit more optimal before you actually pack them. Excuse me. So here I'm trying to actually flatten pieces that I couldn't flatten before and then weld them back. And I believe spacebar actually commits the weld. It's either spacebar or enter. Anytime that you magnetize a piece that you put a weld line on in Headus, to commit it, it will actually have an explanation down at the bottom. But if you can't find any of the hotkeys for this, I would just search for Headus UV layout hotkeys as a search term inside of Google, and you should very easily on the Headus support site find a list of all of the hotkeys that the program uses. So slowly working through some of these, and you know, even if you run optimize and then pack some of these, there still may be some areas where you're going to have to go in and actually size or scale up the UV islands until you know you get less spacing in between the packing order. So packing is basically where it takes all of the UV islands and puts them into a 1-to-1 or 0-to-1 space evenly, right? So that they all fit inside of the UV bounding box. So what you're about to see me do is probably, once I get it optimized, I have to make sure that all of those islands fit within one square, that red outline square. And because I have pieces outside of that box, it's expanding the 0-to-1 space to have other UV planes, shall we say. And so after hitting pack and giving myself a distance for its border, it's going to automatically pack all of those into that 1-to-1 space. And so I'm looking at it checker to see how the seams pair up, and it looks like a lot of my axes did not work right. Ideally, if you can get a lot of the UVs on the same axis, a lot of those texture squares should actually pair up quite seamlessly. Not that it always has to, but for the best results in some of your seams, pairing them up along the same axis would be best. So I think I've got a little bit more fixing and welding to do. And even though I fiddle with this one, I think probably when I did the final, the UV part of it, took, you know, it was probably done within inside of an hour. So you're probably looking at an hour worth of work pared down to about, you know, 12 to 14 minutes. I think this section is probably sped up about 400%. So I'm going around checking, and some of those areas in the UV map where you can see, even with the texture applied, it's turning red. Those may be a little less optimal and or have some distortion. They're absolutely not flattened out perfectly, which perfectly would be ideal. So I'm checking my geometry. I think this is probably closer to my final cage. I think I came back later after doing the topology and did a subdivision preview. And so I can see there are some areas probably where I have to fix some things. I think that was the thing that I did was, you know, trying a few different workflows and seeing what happens best. And then, you know, making the topology fit around the original geometry so that it can get a proper bake going. So here I'm about to do a bake out of Topogun, and I'm sizing up the cage. So when you hit generate maps under the bake menu, one of the first two things that you're going to probably look at is the map width and height. So I think in this bake, I might have mistakenly burned a 1024, or either I came back and adjusted it. But most of the maps that I'm doing are actually 4K or 4096 resolution. So in a square, that's 4096 by 4096. I baked out a normal and an ambient occlusion. So there we go. And sampling would be medium. And I think I had to adjust my cage. So this cage, it goes from the topology that you do that's gray shaded. And then when you set the cage, it takes what's called an octree. And that octree should probably show the reference mesh and how much of it is actually poking through the cage or not. And if you adjust that, what you can do is generally set the cage distance a little bit further, and so that it's totally black and there's nothing poking through, and then you get more of a proper bake based off of the distance that it takes to do a projection. So once I did that bake, I think I went over to Indu inside of the Quixel suite. And Indu is an actual image editor plugin that works inside of Photoshop for the creation of normals. And so you're looking at my baked normal map and me trying to add extra detail to those normals. And I love Indu because you can create normals from scratch, like say if you're doing non-subdivided geometry. But if you are doing subdivided geometry and you're working with a comparison mesh set, so in other words low poly versus high poly to do your bake, you can take and do make new layers in your normal project inside of Indu to add extra detail to the normals. So here I think I added a groove, sort of a pin line cut groove in and around the mesh. This section is probably a UV that sits at the back of the helmet. There's a little mesh section under the back strip of the helmet where it kind of rises up into a sort of a ducktail. And that seemed like a perfect opportunity to use a texture. So I think I had an actual mesh-like texture sitting around that I converted to black and white. And then I copied that to a new layer and using levels just brought out some of the white saturation a little bit and the black as a high point. And then once I bake and put on new normal detail, I can check it inside of Marmoset. And so this is how it looks. Added some of these details, even though I baked in AO and a normal outside of Topogun, I'll probably have to bake a new AO map, either converted inside of Indu or something like nulled, so that it reflects some of the cavities that are in some of the new normal details. So I paint in normal details in Indu in white, and then it has a conversion tool that turns that into RGB information. And from there, that panel on the left-hand side, I can change the shape, bevel, slant, curve, and blending mode of that normal detail. I can also adjust the size slider so that I can adjust the width of, like, say, the line that I put down. The depth is probably going to be default. And then contrast, opacity, and softness. And so after I draw these details out, in fact, I think I had a little Wacom error, that's why that's happening. But after I draw the detail, I think I actually zip the actual folder group that it makes. And that keeps the entire Photoshop document operating a little bit smoothly. So it basically kind of compresses some layers non-destructively. So I could actually go back and either add or resculpt some normal info. So I change the size. And I use linear light, which would probably have a sort of hard punch to the detail. Soften it up a little bit. And next to that zipper icon, if I go one to the right, that's actually the sculpt mode, which is quite handy. if you ever use this application. Sculpt mode allows me to edit normal details that have already been put down. So if I want to cut line or add to that cut line or erase some overage off of the line detail that I converted into normal information, I can hit sculpt mode and actually go in with an eraser and just kind of ebb it out. So I zip it after I'm done, and there we go.